Good day. The topic we are treating today is series by Opola Monsurat Olajumoke. Before the commencement of this topic, you must have been familiar with the topic sequence, its terms and its terminologies, so that by the end of this topic, you will be able to obtain the series of terms of a sequence. Series. A series is the addition of terms of a sequence. Consider the sequence T1, the first term, T2, the second term, T3, the third term, and so on. Adding the terms of the sequence above, that is T1, T2, T3, and so on, starting with the first term T1. If you are very familiar with what a sequence is, you know that T1 is usually, the first term is usually represented by T1, the second term is represented by T2, and so on and so forth. So to find the sum of a single term, a single term will be just the first term, which is T1. So the term is represented by S1, that is your n is equals to 1. So the first sum will be the first term alone, because it means we are adding only the first term. In that particular sequence, we want the sum of only the first term, and that is why we have S1, that is sum 1 equals to term 1. So now, if you want to find the sum of two terms of a particular sequence, it's going to be represented by S2. Your n is 2. That means you are going to add two terms, which is the first and the second term. Also, if you are looking for the sum of three terms represented by S3, is going to be the sum of the first, second, and third term. That is why we have T1 plus T2 plus T3. So up to when we want to obtain the sum for the nth term represented by Sn, which is the first term multiplied by the second term multiplied by the third term, up to the first term added to the second term added to the third term, up to the nth term. That is why we have Sn. So this is the general formula for the sum, that is sum of n terms. Here you can input any value of n starting from 1 to infinity. Here if you have S1, S1 will be equals to T1 alone, S2 will be T1 plus T2, S3 will be T1 plus T2 plus T3, S4 will be T1 plus T2 plus T3 plus T4, and so on. So Sn, which is this, is called a series of n terms. The sum of the series is the value of Sn, that is, if we should add the value of T1 plus the value of T2, if you are given a particular sequence, you have the value for the first term, that is the first number that will come in the sequence. T2 will be the second number, which is the second term. It's going to have a particular value, but it's going to be the second number in that particular sequence. So to get the value of this Sn, you are going to add the value of the first term plus the second term plus the third term up to the nth term. That is why they said the sum of the series is the value of Sn for a given value of n. That is, n we have a stopping term. Assuming n is 7 here, you are looking for S7, which is adding the first term plus the second term to the third term to the fourth term to the fifth term to the 6th term, and then you stop at the 7th term since n equals 7. Given an expression of Sn, that is, if you are given a particular expression for Sn, we can find individual terms of the sequence. If Sn is equals to T1 plus T2 plus T3 up to Tn minus 1, which is the n minus 1th term, plus Tn, which is the nth term. So what you're trying to say here is that if a particular term, if a particular general term is given for Sn, you can find the value of each term from this sum of n terms. That is, if you are given a particular general formula for Sn, from that formula you can obtain the value of the 1st term or the 2nd term or the 3rd term. You can obtain the value of any term of that particular sequence in which you add together to get its series. And you know that Sn equals to adding the 1st term to the 2nd term up to the nth term. And you know Sn minus 1 will be adding the terms of the sequence from the 1st term to n minus 1th term. So here, if you come back here, you know T1 to the n minus 1th term can be represented as Sn minus 1, and that is what we have here. Then Sn will be equals to all this is it here, is equals to Sn minus 1 plus the last term which is not there, Tn. So here, since we are looking for the term of that particular sequence, so the term we make T subscript n the set of formula. T subscript n will now be equals to, this will come to the other side, S subscript n minus S subscript n minus 1. So if you are given the formula for the sum of the terms of a sequence, but you don't know the term of that particular sequence, you can obtain the term of the sequence from the formula given for the sum of term of that particular sequence. So there is a condition that n is a positive integer and the sum of one term is equals to the 1st term. So now we move to examples. So here we have 3 examples. In the first example, we are to find the series of the first 4 terms of this particular sequence. The general term, the nth term of that sequence, is given as 2 raised to the power n plus 4 raised to the power n squared. So here we are asked to find the first 4 terms. The second question, we are given the formula for the sum of a particular sequence, that is the series of a particular sequence. So we are asked to find the 1st term, that is T1, the 5th term, T5, and 12th term. Also, the third question, we are also given the general formula of the sum of that particular sequence, and the 1st term is given, 5th term is given. So in this general formula for the sum of that particular sequence, that is the series of that particular sequence, there are constants A and B. So from this question we have to find the values of the constants A and B. So now we move to the solution of this example. Solutions. In the first question, we are asked to obtain the first 4 terms of a sequence whose nth term is 2 raised to the power n plus 4n squared. So we know that the sum of the terms of a sequence, which is the series, is equals to the 1st term plus this 2nd term plus the 3rd term up to the nth term. Then, since we are asked to find the first 4 terms, that means our n will be equals to 4. So now we are asked to obtain the value for S4, which equals T1 plus T2 plus T3 plus T4. So now from the formula of the n term given, that is T subset n equals 2 raised to power n plus 4n squared, we start by inserting the value of n starting from 1 up to 4. That means we find the value for T1 when n equals 1, the value for T2 when n equals 2, the value for T3 when n equals 3, and the value for T4 when n equals 4. So T1 will be equals to 2 raised to power 1 plus 4 into 1 squared. So 1 squared will give 1, 1 multiplied by 4 will give 4, 2 raised to power 1 is 2, 2 plus 4 will give 6. So the value for the first term of that particular sequence that has its general term to be 2 raised to power n plus 4n squared is 6. So now we look for the value for the second term, which is when n equals to T2 will be equals to 2 raised to power n, which is 2 raised to power 2 plus 4 multiplied by 2 squared. 2 squared is 2 multiplied by 2 to give 4. 4 multiplied by 4 will give 16. 2 raised to power 2, which is 2 multiplied by 2 is also 4. 4 plus 16 will give 20. So now we apply the same formula, the same procedure to obtain the third term T3, which is 2 raised to power 3 plus 4 multiplied by 3 squared. 3 squared is 9. 9 multiplied by 4 is 36. 2 raised to power 3 is 2 multiplied by 2, which is 8. 8 plus 36 will give 44. Also for the fourth term, 2 raised to power 4, because our n is 4, plus 4 multiplied by 4 squared, because we have 4n squared and n is 4. 4 squared is 4 multiplied by 4 to give 16. 16 multiplied by 4 will give 64. And 2 raised to power 4 is 2 multiplied by 2 multiplied by 2 multiplied by 2, which is 16. 16 plus 64 will give 80. Now, we know the values for the first, second, and third and fourth term of that particular sequence. So we find the sum of the four terms of that particular sequence, which will give the value for S4. So here S4 will now be T1, which is 6, plus T2 20, plus T3 44, plus T4 80. So we should sum all this together. We are going to get 150, because 6 plus 20 is 26. 26 plus 44 is 70, and 70 plus 80 is 150. So the sum of the first 4 terms of a sequence whose nth term is T substrate n equals 2 raised to power n plus 4n squared will be 150. Assuming you are asked to find the sum of the first 6 terms, we proceed to finding the value of the 5th term T5 and the 6th term T6, and S6 will be equals to the first term plus the second term plus the third term plus the fourth term plus the 5th term plus the 6th term. So that solves the question. Now we move to the second question. Question 2. We are given the formula for the sum of a particular sequence. So from that formula for the sum of this particular sequence, we are asked to obtain the first term, the 5th term, and the 12th term. So from above, we already know that S1, that is sum of one term, is equals to the first term, and the general formula given by that sum of that particular sequence, that is the series of that particular sequence, they already obtained a general formula for it, which is n squared minus n plus 1. And we know that this first sum, that is sum of a single term, is equals to only the first term. So to obtain the first term will now be inputting the value of n to be equals to 1. If you should find the value of s1, it's going to be 1 squared minus 1 plus 1. And since s1 equals t1, t1 will also be equals to 1 squared, that is the value of n equals 1 minus 1 plus 1. And 1 squared minus 1 will give 1 minus 1, which is 0. 0 plus 1 will give 1. So the value of the first term of that particular sequence that has the formula for a sum, that is a series, to be n squared minus n plus 1 is 1. So now we proceed to obtain the value for the fifth term. From above, we already said if you want to obtain the value of the particular term of a sequence from the formula of its series, the formula will be t subscript n equals the series of that particular term minus the series of the previous term. So here we are asked to obtain the value for the fifth term, that is our n will be equals to 5. So t5, which is what we are to obtain, equals s5 minus s5 minus 1. So it will be the value for the fifth term will now be s5 minus s4. So we are already given the general formula for the sum, that is the series of that particular sequence. So to get the value for s5, we substitute the value of n to be equals to 5 and subtract it from substituting the value for n equals to 4. So now we proceed. So when we substitute the value for n equals to 5, we have n squared minus n plus 1, which will be 5 squared minus 5 plus 1, minus when n equals to 4, 4 squared minus 4 plus 1. So 5 squared is 25. 25 minus 5 is 20, and 20 plus 1 will give 21, minus 4 squared. 4 squared is 16. 16 minus 4 is 12. 12 plus 1 is 13. That is why we have 21 minus 13, which is 8. So the fifth term of that particular series that has its general formula to be n squared minus n plus 1 is 8. So the fifth term is 8, the first term is 1. So now we obtain the value for the 12th term, and that is t12. Here our n is 12, which will be equals to sn minus sn minus 1, which is s12 minus s12 minus 1. That is s12 minus s11. So now the value for n is 12. Substitute from when the value for n, we subtract in it from when the value of n equals to 11. So here when the value for n equals 12, we have 12 squared minus 12 plus 1 minus the value for n equals 11. 11 squared minus 11 plus 1. Here 12 squared is 144. 144 minus 12 will be 132 plus 1 give 133. So here 11 squared is 121 minus 11 will be 110 plus 1 to 111. So if you subtract 111 from 133, then we have 22. Therefore, the 12th term of that particular sequence that has a series to be n squared minus n plus 1 is 22. So here we know the value for the first term to be 1, the value for the fifth term to be 13, to be 8, and the value for the 12th term to be 22. So here we can also find the value for the second term up to any term. So now we move to the third question. In the third question, the sum, that is the series of a particular sequence, is given as a(n squared plus b(n), but we don't know the value for the constants a and b. And also in the question, we are given the value for the first term to be -1 and the value for the fifth term to be 15. So we are now asked to obtain the value for the constants a and b. We all know that the sum of a single term is equals to first term. And here, if you have to find the sum of single term, you know the value for n will be equals to 1. So S1 here will be a, 1 square is 1. 1 multiplied by a is going to be a, plus b multiplied by 1 is b. So S1 is a plus b. And we already know that the sum of one term is equal to the first term. So we can also say that T1 equals a plus b. From the question, the value for T1 is -1. So we can say -1 equals a plus b. And that gives the first equation. So now, also, we know that if we want to obtain the particular term of a sequence from its series, from the formula of its series, is given by the formula T subscript n equals Sn minus Sn minus 1. So assuming we want to find the value for the fifth term from the formula of its series, we know T5 will be equals to n, the value for n will be equals to 5. T5 will be equals to S5 minus S5 minus 1, which is S4. So let's obtain the value for S5 from the general formula of the sum of that particular sequence, which is an squared plus bn. So assuming our n is 5 here, we have a5 squared plus 5b, and 5 squared is 25. That is why we have 25a plus 5b. So minus S4 will now be 4 squared multiplied by a plus 4 multiplied by b, and 4 squared is 16. 16a plus 4 multiplied by b will give 4b. So now we open the bracket, we have 25a minus 16a to give 9a, and also 5b minus 4b will give 1b, is also b. So now we have T5 to be equals to 9a plus b. That is, if we want to obtain the value for T5 when we are using the general formula of its series. And from the question, the value for T5 is already given as 15. Therefore, 15 will be equals to 9a plus b, and that gives the second equation. Equation 1 and 2 leads us to a simultaneous equation. So we eliminate b. We use the method of elimination. We eliminate b by subtracting the first equation from the second equation. So subtracting equation 1 from 2, we have, equation 1 is equals to -1 equals a plus b. So 15 minus -1 will be 15 plus 1 will give 16. 9a minus a will give 8a, and b minus b will give plus 0. That is why we have nothing here. So we divide through by 8 to obtain the value of a to be equals to 2. So now we know the value of a. We substitute the value of a into either equation 1 or 2 to obtain the value of b. But here in this lesson, we choose to substitute the value of a into equation 1, and the statement for equation 1 is -1 equals a plus b, which will give -1 equals the value for a is 2 plus b. So we collect like terms, 2 we move to this side, and we have -1 minus 2 equals b, and -1 minus 2 will give -3. Therefore, the value of the constant a and b is 2 and minus 3 respectively. And if you substitute this into the nth term of the series, it's going to be, we have an squared minus bn. So the value for a is 2. So the nth term of the series now be 2n squared minus 3n. And that completes the solution of the example. So here we move to exercises. We have to solve these exercises to check if we really understand what we have been explaining. Next video will be on sum of arithmetic progression with sample questions and solutions. Please subscribe to our YouTube channel, like and share our videos. Thank you.